Hi, I'm Mark Donovan, Director of Commercial Applications for Audio-Technica US, and I'm back here again with System 20 Pro to go into a little bit more detail. And right now what I want to talk about is just how this system can survive in a 2.4 gigahertz environment. Now, of course, we're all familiar with Wi-Fi, and that 2.4 gigahertz Wi-Fi band, there's a lot of stuff going on. You're talking about Bluetooth and Wi-Fi, people's phones and computers and laptops and everything else. And there's just a lot going on inside of the spectrum. And a lot of it is moving target. And so how can we deal with that? How are we able to be successful for the last decade with this technology? And I want to go into that a little bit. So first of it has to do with its smart frequency management. So when the system turns on, the receiver is going to listen to that environment, and it's going to listen to hear where is that Bluetooth device, where is that Wi-Fi device, where are those computers. So it looks at all that space and it finds a free area, a free space for our system to operate. Now, then it's going to actually uplink. So it transmits from the receiver to the transmitters to tell the transmitter what frequencies that it is able to operate on. And those frequencies are based on where it found that clear space, and also understanding that our signal is actually quite a bit narrower than like a Wi-Fi channel. A Wi-Fi channel is typically going to be in that 20 megahertz range as far as how wide it is, where ours is only just a little bit over a megahertz. So it's a very narrow signal. And so it uplinks that information to the transmitters, and then the transmitters receive that. They downlink their information, the audio information, control information, like, you know, what's the status of the mute switch, and it downlinks all that back down. Now, it goes through that process not just once or twice, but it continually repeats that thing. Actually, it's multiple times per second that it's repeating that. It continuously evaluating, continuously changing if it needs to. So that way, it's going to find a nice stable frequency. It sits there transmitting it. Somebody comes into the room and turns on a device or brings their phone in. If that's in the way, then that's fine. It can move. Now, if you remember, I said frequencies, plural, when I said an uplink from the receiver to the transmitter. That's because the transmitter actually has two of those narrow frequencies that it's transmitting on, a primary and a secondary. And they're actually offset in time ever so slightly when it transmits it back. And when I say ever so slightly, I'm talking microseconds, not milliseconds. So they're offset in time just a little bit, so that if that individual comes in with their laptop or their phone and it interferes with that primary, that first one, that second frequency still contains the information and it's still going to get to the receiver intact. And then that next cycle rolls around, it picks new frequencies again. So this has really given us a very stable system. Now, to further that, what happens when you have multiple systems in there? Like I said, this receiver rack here, I said in an earlier video, I said this receiver can actually handle 4 channels. But what if I have 8 channels or 12 channels? What about that? How are they all going to work together? Well, actually, on the very back of the device, there are some RJ11 connectors. They're link cables. And what these link cables do is they connect all of the receivers together and communicate the information that's important, such as frequency plan, but also timing for those phases, so that all of the transmitters are transmitting their downlink data at the same time, so that the receiver has a quiet area to listen, so that each of those 3 phases, the listen, the uplink, and downlink, all occur at the same time frame. So this allows us to keep that clean environment and coordinate those multiple channels. So all of this leads to an extremely stable system, but it still comes down to one more thing, one key thing, and that has to do with the antennas. And the antennas, this has always been a difficult thing when you're talking about 2.4 gigahertz, because this connector on here, and I don't know, maybe some of you have worked with this type of connector before. This is an SMA connector. And at this frequency, it's using this smaller connector, which is much more expensive. It's using a different kind of cable than you would use on a typical UHF wireless, which is much more expensive, and it's also got a lot of loss to it. So even just taking and trying to remote this antenna just a few feet, you're going to have such a great deal of loss in that cable that your RF stability is going to drop. So when the engineers designed this system, what they realized was that the transmit and receive package for this is actually fairly compact. And so you could actually remove this from the chassis. And so now I have this very small transmit and receive package, which, by the way, this just one package here can receive 4 channels of audio. And I can simply connect it with a category cable. So I can run a Cat5 cable from this receive point back to your rack. And we've even included in the box a nice little wall mount box. So I can actually keep this nice and clean, have this mounted on a wall. That way, like I said, you can keep it clean. It hides the wire and everything. But the key with this, of course, and with any high frequency, is you need to get this into the room where you're being used. That good signal to noise is what wins the day when you're talking about digital audio. So, that system that we've employed, all those different steps, the ability to remote the receiver, this has been what's really led to the success of System 10 Pro, the predecessor, and of course System 20 Pro now. So that's it in a nutshell on how this is working and how we succeed at it. Thank you for joining me.